Hello everyone, and welcome to the implementation of merge sort lecture. So, again as a brief overview, merge sort is a recursive algorithm that continually splits a list in half, list or array. If that list is empty or has one item, by definition it's already sorted, that's your base case. If the list has more than one item, we're going to split that list recursively and invoke a merge sort on both halves. Once the two halves are sorted, the fundamental operation called a merge is performed. That merging is the process of taking two smaller sorted lists and then combining them together into a single sorted new list. So here I am at the implementation of merge sort notebook, which is under sorting and searching folder. Here's your resources for review, and then here's the actual function we're going to implement and explain as we go along. So let's go ahead and implement it, make sure it works, and then break it down line by line. So I'm going to go ahead and hop over to a Jupyter Notebook here, and I'm going to go ahead and start typing out. So first thing we're going to do is just say def merge underscore sort. And we're going to go ahead and pass in an array or a list, same thing as we've discussed before. And I'm going to say if length of this Python list, which we're treating as an array, is greater than 1, then I'm going to have some code out here. So I'm going to say mid as a variable. So if we already have a length that's more than 1, we know we're dealing with a list. So I'm going to say that middle of that list, that mid mid, is going to be the length of that array divided by 2. And then I'm going to create two halves, the left half of that array and the right half. So I'm going to say left half is equal to array, and I'm going to use some slicing here. I'm going to say left half is everything to the middle, and then the right half is from the middle onwards. Alright, so we're using that MID, that variable, as a midpoint so we can split that array. And here, we're actually going to do a recursive call. I'm going to say merge sort on the left half, and then I'm going to call a merge sort on the right half. And I'm just using tab to autocomplete those variables, which is why they're popping up so quickly. Alright, so then we're going to go ahead and make basically some index variables as counters. So I'm going to say I equals 0, j equals 0, and k equals 0. Alright, and then we're essentially going to have 3 while loops here. One to check basically that midpoint, and then another one for the left and right half. So let's go ahead and program these out. So I'll say while I is less than the length of the left half, and j is less than the length of the right half, what we're going to do is say if the left half at that index is less than the right half of that index of j, then we're going to say the array at the k index, that value, is equal to left half of I. And then we're just going to say I equals I plus 1. And then let's go ahead and zoom in on this loop here. Then I'm going to say else the array value at that index k is equal to the right half of j. And then we're going to add a value to j. We're just going to say j equals j plus 1. And then outside of that, we're just going to say k plus 1. And just as a reminder, this is the same thing as saying k equals k plus 1. Okay, so that's our first while loop. And something to note here is that these additional while loops are really just operating for merging two smaller sorted lists into a larger sorted list. So notice that the merge operation places the items back into the original list, which in this case is ARR for us. So it replaces them, places the items back into that original list, ARR, that array, one at a time by repeatedly taking the smallest item from the sorted list. Okay, so let's go ahead and continue on with the rest of the code we need for actually merging these two sorted lists. So as far as the actual sorting, that's happening here at the recursive call. But we have two more while lists for continuing this merging of these two sorted sublists. And they just have to do with the left and right half. So we're just going to say while I is less than the length of the left half, then our value at k is just equal to left half value at I. I'm going to say add counts to those index markers. And then we're going to do the same similar thing for the right half. So then while j is less than the length of the right half, that value at k is equal to right half at j. And then similarly, we're just going to say j plus 1, j plus equals 1, and then k equals k plus 1 there. Okay, so I know that's actually quite a bit of code that we just did. So before we break it down line by line, we're just going to go ahead and make sure it actually worked out for us. So let's go ahead and make an array of some random numbers that are unsorted. Okay, and then let's call merge sort on that array, and then check the array. Okay, great. Looks like it worked, and looks like it was all sorted. So now let's go back again and check this out line by line, really make sure we understand what's going on here for the merge sort, and we remember that it's basically a recursive call on this sorting algorithm. So first off, we basically have in the base case, right? And we're checking here and doing the recursive calls. So we're saying if the length of the array is still greater than 1, which means we haven't reached that base case of just one element in that list, we calculate the mid and then split that list into left and right halves. And then we call merge sort on left half and right half. So you can imagine as you keep calling this recursive algorithm, if you remember back to the figures of the previous lecture, you keep splitting that list in half. All right. And then once those two halves are sorted, we basically have that fundamental operation called a merge. And the merging is just the process of taking those two smaller sorted lists and combining them together into a single sorted new list. So we basically have three different index trackers, where the k index tracker is going to relate to our final array. And then the I tracker is for the left half, and the j tracker is for that right half. So each three of these while calls here is just to make sure that the index is actually still within the left and right half of the list, which is why they're just less than calls. So we have our I index for that left half, and here we're just checking, okay, are we still in that left half? And then j is just checking, are we still in that right half? So then we're just checking at that particular index of I and j as we continue on, because remember we're adding them essentially equally for any if or else cases. We're saying which one's less than or greater than. So if it's less than, then we just set the value at that current k equal to the left half, and then we add to the I value there. Once we've done that, we go ahead and add to the k value. If this wasn't the case, then we actually set the value equal to the right half, and then add 1 to the right half index marker. Then we have while I is less than the length of the left half, we continue on with a similar process, add I plus 1, k plus 1, and then the similar thing for right half. If it's still inside right half, go ahead and set that current value to right half of j plus equals 1, k plus equals 1. You're just constantly adding counts and making sure you're still within that left half and right half markers. So these three while loops are just doing the actual merging of the sorted sublists. So let's just break down this code one more time as a complete whole picture. I'm kind of zoomed out a bit. But basically what we have here is our merge sort function. It begins by asking that base case question. If the length of the list is less than or equal to 1, then we've actually already have a sorted list and no more processing is necessary. If on the other hand the length is greater than 1, then we use the Python slice operation, which is what we're doing here, to extract the left and the right halves, which is this variable and this variable. And it's important to note that the list may not have an even number of items. That actually doesn't matter, as the lengths will differ by at most 1 if it's an odd number of elements. So then once that merge sort function is invoked on the left half and the right half, these two lines here, it's assumed that they are sorted. And what's actually happening for the rest of the function, the rest of these lines, they're responsible for merging the two smaller sorted lists into a larger sorted list. So notice that that merge operation places the items back into the original list. So we're actually placing them back into ARR, that original array that we took in here at the top. So it's placing them back one at a time by just repeatedly taking the smallest item from the sorted list. So you notice here we're always checking for the smallest item when we're doing these merging operations. So one more useful tip as far as really understanding what's going on is definitely adding print statements. So you could even just say here in line with that if we go ahead and go back, we can actually just say print, and we can say merging, and then let's go ahead and say just that array. Let's make sure that rhymes or works. And here we can see the actual arrays we're merging. So this is a really nice visualization, and hopefully you can see how it matches up with that original diagram that we saw in the last lecture. So we're merging 11 and 2. So these guys have already been merge sorted all the way until they only have one element left in their index. So let's zoom in a little more so you can really see this. So we're merging 11 and 2, we're checking which one is less, and now we have a sorted. Now we're going to the right half, taking 5 and 4, merging them and sorting them. And then we're going to go ahead and merge these two guys, so now we have them sorted. And you can see how we have the recursive calls on these arrays, or these sublists. And you can see how we're combining them and merging them. So go ahead and walk through this. What I would recommend is that you actually replace this array with the same array we used in the previous diagram, so you can actually match up your code to the diagrams and figures we saw in the last lecture. Okay, so that's it for the merge sort. Probably the most tricky or confusing part is making sure the merging itself is actually checking correctly on these 3 while loops. But the actual idea of it and the recursive call should be pretty simple and straightforward, especially if you've already done the recursion section. This sort of method of sorting just kind of makes sense that you would keep splitting that list in half, more and more and more, and then just slowly sort them and merge them as you go back up. Okay, that's it for the merge sort. You can go ahead and check out the Jupyter Notebook in case you want more resources for review, more explanations, and check out the previous lecture if you want those actual diagrams. All right, thanks everyone, and I will see you at the next lecture.